This is 6.2, more trigonometry. Now, this lesson we're going to be talking about right triangles. Hopefully, in your prior classes, they hounded what right triangles, the relationships between that. So basically, you have the adjacent side, the opposite side, and the hypotenuse based off of the theta, the angle measurement that it's referring to. So this would be the opposite side, the adjacent side, and of course the hypotenuse, which is the diagonal side, opposite the right angle. All right, so the trig functions, sine, we've already discussed this really briefly, but sine is opposite over hypotenuse. By the way, this is where a lot of people memorize SOHCAHTOA, and basically if you focus on sine, cosine, and tangent, so you literally have SOHCAHTOA, SOHCAHTOA. And that's the relationship. And then, of course, remember cosecant, secant, and cotangent are the reciprocal of those. All right, so let's move on to this is basically all the information based off of a 30, 60, 90, 45, 45 degree triangle. These are called special common values of triangles. These two triangles you're going to see a lot of. These angles happen in real life a lot, even in construction. And so here's a chart. You don't need to memorize the chart, but you do definitely need to know the relationships between a 30, 60, 90 triangle and a 45, 45. So a 30, 60, 90. So opposite of 30. So remember 30 degrees is the smallest angle on this triangle. So opposite of that is 1. And then 60 degrees is square root of 3, and then opposite the 90, or the hypotenuse, is 2. So 1 square root of 3, 2. So even if I gave you a triangle, and I told you it was a 30, 60, 90, and if I said this is 5, well, if this is 5, then I know that, opposite of this is the shortest side, 5, and this is basically 1 times the square root of 3, so this would be 5 square root of 3. And this is going to be 10, so literally the 1 and then the hypotenuse is twice that. So if you know the relationship between a 30, 60, 90 degree triangle, then you can easily figure out all 3 sides between them if you're given one side. Similarly on a 45, 45. So obviously 45, 45, that means opposite of this, opposite of that, they're going to be equal. So even if I gave you a 45, 45, and I said solve the other angles, if I said this is 5. Well, if that's 5, then this means this side is also 5, and then this is just being multiplied by square root of 2, so 5 square root of 2. So you can memorize this chart up here if you want, but if you know the relationship between this, you should be able to answer all of these questions. So here's some degree symbols. Here's the radian measurement of those signs. Again, the unit circle is going to come in handy, knowing this as well. Sine, cosine, tangent. Cosecant, secant, and cotangent. Again, knowing the unit circle is going to come in handy for this, and also these special triangles. All right, so let's say this problem says find the 6 trig ratios of the angle theta in figure 3. So again, sine of theta is opposite over hypotenuse. And so sine, here's theta, so opposite over hypotenuse would be 2/3. And again, keep in mind the right angle is here, so the hypotenuse is opposite of that, so 3. And always remember also the hypotenuse is always the longest side. All right, so sine is that, which means cosecant of theta is 3/2. Remember, it's just the reciprocal. Cosine of theta is adjacent over hypotenuse. So adjacent over hypotenuse would be square root of 5 over 3. And then secant is the reciprocal of that, 3 over square root of 5, or 3 square root of 5 over 5, if you simplify that. And then, of course, you got tangent. Tangent is opposite over adjacent. And so that would be 2 over square root of 5, or 2 square root of 5 over 5. And then cotangent is the reciprocal of that, square root of 5 over 2. All right, so I found all 6 trig functions based off of theta. So here, similar, I have a cosine of theta, or in this angle here equals 3/4. Sketch a right triangle. So we're going to draw a right triangle, and here's my angle measurement. Cosine, remember, is adjacent over hypotenuse. So adjacent would be 3, and then the hypotenuse would be 4. And then, of course, I don't know this side right here. I don't know that side. So if you remember the Pythagorean theorem, so this would be 4 squared equals 3 squared plus b squared. So we're trying to find the missing side. So 16, 9, so when you solve it, you're going to get plus or minus the square root of 7. But keep in mind, we're talking about measurement, so it can't be negative. All right, so it's automatically square root of 7. So this is the square root of 7. And then it says find the other 5 trig functions. So we already know what cosine is, so we're just going to worry about sine and tangent. We're going to go ahead and write cosine, just because that's 3/4, and we got to find the other ones, which is secant. We got to find cotangent, and we got to find cosecant. So cosine is 3/4, that's already given, and then sine, and everything's based off of this angle here. So sine is opposite over hypotenuse. So opposite would be the square root of 7 over hypotenuse is 4. Tangent is opposite over adjacent. So square root of 7 over 3. And then the other ones are just all with the reciprocal. So 4 over 3. This would be 3 over the square root of 7, or 3 square root of 7 over 7. And this would be 4 over the square root of 7, or 4 square root of 7 over 7. Using a calculator, so again, you might want to grab your calculator and solve these. Now these, I do want to mention these are in degrees, so make sure you're in degree mode, not radian mode. So check your values, grab your calculator, check your values, and again, make sure you're in degree mode. All right, so here it says solve triangle ABC shown in figure 7. So solve means we need to find everything. So angle A we already know, angle C we already know. This automatically means this angle B is 60 degrees. Now there's a couple ways we could do this. I would probably start off with what I do know. I would start off with a 30-degree angle. And I do know the hypotenuse. So what I would probably do is set up the sine function. So sine of 30 degrees is opposite over hypotenuse, so that would be A over 12. And then to solve this, you're going to multiply by 12. So A equals 12 times sine of 30 degrees. And then when you type that in, I'm going to get 6, because sine of 30 is 1/2. All right, so, and then, which by the way, I didn't even technically have to do that. I just want to let you know that is one way you could do it. But remember the relationship between a 30, 60, 90 degree angle? So if this is 12, and by the way, we could find B a couple ways. Let me go and finish this. Let me go and find B one other way. So there's one way we could have done that, and then we could also do cosine. This is one way you can do the problem. So we could do cosine of 30 degrees is B over 12, and then find B in that case. So we could do it that way, just multiply by 12, all right, and we could do it that way if we wanted to. But another way we could do this is use the Pythagorean theorem. Started writing the formula of a circle. So C squared equals A squared plus B squared. So once we know the hypotenuse is 12, and we find one side is 6, then we can find B squared. Okay, that's another way to do it. So without any of that, so if I didn't have any of that whatsoever, one way we could do this one way we could do this, because this is 30, so remember the relationship between a 30, 60, and 90 degree triangle. So if this is 30 degrees, remember, generally speaking, this is 1, this is 2, and this is 1 times the square root of 3. So if I know this is 12, I automatically know this is half of that, which is 6. And then this would be 6 square root of 3. So without any really trig functions involved, if you know the relationship between a 30, 60, 90 degree triangle, you can do it that way as well. So I showed you several ways you can get to the answer on that. And again, you got to solve all the sides and all of the angles. So we already found all the angles, and then now we found all the sides. So for the last problem, here's an example. So a giant redwood tree casts a shadow of 532 feet long. By the way, the picture I added here for the notes, but you should be able to draw the picture based on the words. So, you know, when you're doing a word problem like this, if it says a tree, I would draw a tree. And then it casts a shadow. So I would make a sun that makes a shadow. And obviously the shadow is 532 feet long. And it tells you that the angle is 25.7 degrees. And all you're trying to do is find the height. So, you know, what trig function could we use? So we do know the adjacent to the angle, and we're trying to find the opposite. So this means I'm going to use the tan function, tangent. So tangent of 25.7 degrees, tangent is opposite over hypotenuse. So notice, you might want to pause the video and make sure you understand how to set that up. But I'm going to set that up, and then I'm going to solve this, multiplying by 532. And it's going to find the height of the tree. So we have the height of the tree is approximately 256.03 feet in the air. That's trig functions working with right triangles.